Okay, let's look at the chain rule, right? So chain rule applies to the composition of two functions, let's say f of g of x, right? So if you want to take the derivative of f of g of x, what you need to do is take the derivative of the outside function. So f prime, then leave the inside function as it is. So you have f prime of g of x, then multiply by the derivative of the inside function, right? So here's an explanation for why this is the case, right? So let's let the y equals f of g of x. So we want to take the derivative of that, right? Then let u equals g of x, right? So we can rewrite the f of g of x as f of u, right? Right? So if you're looking for the derivative of f of g of x, right? And we can, since this is a derivative of y, so we can write it as a dy over dx, right? And can we convince ourselves that the dy over dx is equivalent to dy over du times du over dx, right? So you can treat these like fractions, and you can see that you can cancel du and the du here. You're gonna get back dy over dx. So these are equivalent, right? But what is dy over du? So this is the derivative of f of u with respect to u. So another way to write that is simply f prime of u, right? Then multiply by du over dx is just the derivative of g of x with respect to x. So you would have g prime of x, right? But remember that the u is same as g of x, so we can just put that in. So we have f prime of, right, u is g of x, right, times g prime of x, right? So that's why we have this chain rule right there. So it checks out. All right, so there's a special case of this chain rule called the general power rule when outside function is a power function, right? So let's look at that. So if you want to take the derivative of g of x to the n, then what you have to do is, since the outside function is a power function, so we just apply a power rule. So put n in front, right? Keep the inside function as it is, so you have a g of x, right? Subtract 1 from the power, so this is just a power rule, so n minus 1. Then chain rule, multiply by derivative of the inside function, right? And this is called the general power rule. It's basically the combination of the power rule and the chain rule. All right, so let's look at a couple of examples. All right, so first one is a general power rule, right? So let's take the derivative. So if you want to find y prime is equal to, right? So power function, put 100 power in front, keep the same quantity inside, so that's g of x, so 2x squared plus 3x plus 1, right? Then subtract 1 from the power, so it's going to be a 99 power, right? Then multiply by derivative of the inside function, so derivative of x squared is 2x, and 3x, derivative of 3x is 3, and derivative of 1 is 0. So that's that, right? So this is the derivative of quantity x squared plus 3x plus 1 raise it to the 100th power. All right. How about the next example? if you have y equals e to the x squared plus 3x plus 1. All right, so we want to take the derivative of that. All right, so let's do that. So y prime is going to be equal to, all right, so outside function is exponential function, and then you have this inside function plugged in. All right, so derivative of the outside function, which is e to the x, so it's going to be same thing. So what you do is you just copy exactly the same thing, so e to the, and leave the inside function as it is, right, which end up just copying the same function, right, then multiply by derivative of the inside function, which is 2x plus 3, right, and that's the derivative using chain rule, and of course exponential rule. All right, that's it. I hope that this was clear.